Okay, page 8. Number 4. Okay, you're going to be able to have a calculator tomorrow, but I want us to practice the steps without a calculator, especially some of the problems involving use substitution. So let's start with A. So for area, we always want to try to explore top minus bottom first, right? Only if something doesn't quite work out, then we'll look at something else. But top minus bottom is typically going to be the first option. In this case, we can, right? Top graph is the curve, the x e to the x squared. The bottom is the negative 2x. There's no sudden shift in the top curve changing. There's no swap. So top minus bottom here. So the area should be easy to set up, but I want us to practice working this out by hand. Thank you. All right, so this 2x is pretty easy. We know that's power rule, but this x e to the x squared, we don't have a nice rule that can look like this. But if we go through use substitution, we can make it turn into a rule that we normally use often. So just to kind of step to the side here. If we go through use substitution, what's the u value that will allow this to work out cleanly here? What do you guys think? Yeah, x squared, right? So if we target this x squared, we can hopefully make it turn into e to the u. The x hopefully will cancel out. There may be a coefficient, but we know we have a rule for e to the u, right? E to the u is just e to the u. Bless you. Okay, so things are beginning to take shape. We see the x's go away. We can push the 1/2 out in front. And now we have a nice clean rule for e to the u. We know e to the u is just the function itself. So the antiderivative of e to the u is just the same function, e to the u. But we took care of the x. We kept track of the coefficient. And now we know the result of this is just 1/2 e, and we'll bring the x squared back into the answer, into the antiderivative. So here's the antiderivative results. We know 2x becomes what? What's power rule for 2x? Yeah. Okay, so once you do the calculus, then you can work the bounds in. Upper bound gets inserted first. Minus parentheses, now we involve the 0. So here's something that we have to be careful about. Yes.
Can we not just use our calculus?
Yes, but I want us to practice going through, use substitution, the thing we have to be careful about 0 is, yes, the majority of the time 0 will wipe everything out, but something dealing with exponential functions, it may not always go away as cleanly as you would like. So make sure that you spend the time to insert 0 into your expression, because sometimes you may not be dealing with everything being 0. Okay, like in this case, right? If I insert 0 in for x, I get 1/2 e to the 0 squared, and what's e to the 0? Yeah, e to the 0 is 1, right? E to the 0 is not 1. It's not 0. So 1 times 1/2 is 1/2. So there's still 1/2 left over. Okay, try part B. Now part B is just setting up. Don't have to go through the calculus for part B. It says write, but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals -2. So see if you can set that up. Anytime you see the word rotation, you know it's going to be a disk or washer method. So make that decision whether you're dealing with disk or washer. Try part B. Okay, part B. Right, so we see that the axis of revolution is clearly not up against the flat surface of the shaded region. Just because it's touching the graph is not enough for it to be this method, right? So if you see any sort of a gap, you got to account for the fact that there is a hole or that we have to subtract out. So extend from the axis to the shape to the furthest boundary for your big R, your little r from the dotted line to the closer of the shaded region boundary, and then top minus bottom for both. And then set up your washer method.
Why is the bound from 0?
Because we are stacking these circular disks from this end all the way to this end. Okay, and also I think that's something that to bring up as well, is that your axis of revolution does not play a role in your boundary for shaded region ever, right? So sometimes a lot of students get thrown off by the axis of revolution. They feel like the axis is going to have to play a role in the bounds, but the bounds is just for the shaded region only. Okay. So your axis can be all the way down at negative 100. It's not going to impact your bounds. Okay. Oh, and also to add to that, we know that the -2 cannot be a bound because everything has to be in terms of x. And we see that this is not an x value. So hopefully that was also a red flag that if you start using -2, that, wait, all these are x's and suddenly I have a y, you know that there has to be a consistent variable for everything inside your integral notation. Okay, let's turn to page 9. Again, I like for us to practice working this out by hand. So part A, find the area. So it looks like this is top minus bottom, right? There's nothing that is strange about this region. There's no need to change it to right minus left. Okay, the top graph is the linear graph, the 2x, and the bottom graph is the curve, the x squared. All right, go through power rule. Then you can work in the bounds. If you're working anything by hand, you can always leave your answer unsimplified. Okay, any questions with A? Okay, part B, the region R is the base of a solid. For the solid, the cross-section perpendicular to the x-axis, right? First decision we always make is which direction is this base? Is it vertical or horizontal? Perpendicular to the x-axis, x-axis is this direction. Perpendicular to it means it's vertical. So we're dealing with a vertical base. So we can just connect that distance here. But here's something strange is that it's giving you the area already. So this is one of those problems where we don't have to build anything from scratch. We don't have to build the base and then adapt it to the area and then to the volume. So here's the cross-section formula. Or volume of cross-section is the definite integral of the area dx. Now, normally we have to find the area on our own, right? Find the base, decide which shape we're dealing with, whether it's a semicircle or rectangle or square or triangle, and then we build and we fit it into that area. But here, this problem is already giving us the area, so really as simple as just inserting this directly into the integral. Right? We don't have to go through the steps of finding the area because it's already given to us. Now, part C is also cross-section, and part C is then this becomes more of a traditional cross-section problem where we have to build our area from scratch. But here the area is already given, so we can just insert that right in. However, I like for us to practice working this out by hand. This is going to be a little bit of U substitution. What's going to be the U value here? Pi over 2x. Okay. Now we can go through the full U substitution step, which is fine. But the shortcut that I want to remind us about is that the leftover that's going to come out of that U value is just going to be the flipped version of the derivative. Okay. So what's the derivative of pi over 2x? Just what? Derivative of 2x would just be 2, so the derivative of pi over 2x would just be pi over 2. And then you flip that, so what's the flip version of pi over 2? 2 over pi. So that's really all that's going to happen there. If you went through your substitution, you'll be able to see that occur as well. But typically for the simpler U values, if you're going through U substitution, just take the derivative and then flip that value, and that is what is going to come out of that process. Okay, now sine's antiderivative is negative cosine, so it's basically just negative cosine of pi over 2x, and then the leftover is that 2 over pi, and then we know there's a negative that's going to come from that sine turning into a cosine. Right. But if you want to go through the full U substitution step, you can. It's just a nice shortcut for the simpler U substitution problems. Okay, so now once you have your antiderivative, you can work in the bounds from 0 to 2, upper bound first. Cosine of pi is -1, so -2 over pi times -1. Cosine of 0 is 1, so 2 over pi plus 2 over pi is 4 over pi. Okay, so now part C is more of a traditional cross-section problem, right? So look at the orientation that you're building your base. Once you find your base, determine what area formula you're trying to insert into. put into the area formula, and then the volume formula. Okay, so read part C, give that a try, and I'll go over the steps. Okay, what adjustment do we have to make for part C here? Yeah, we're dealing with, it says perpendicular to the y-axis. Right? Y-axis is this direction, perpendicular. So anytime you see a horizontal rectangle or base or radius, you know your equation has to be rewritten in a more usable form. Sorry, X, Y, equals 2X. Okay, build the base. Right minus left. Identify the area. We're dealing with a square. Formula is base squared. Update that area with the particular area. Now you're ready for the volume. Again, I know it's maybe tempting to include pi in front, but you only do pi for circle-based formulas, right? This method or wash method. That's the only time you involve pi in front, or semicircles, but with pi over 8. But typically with cross sections, we don't involve pi in front. Okay, the bounds have to be adjusted as well. We have to use y values. We have to go from 0 to whatever the highest y value is. The highest y value is 4. And it's only asking for the setup, so that's good enough. I created a part D here. If you guys can try part D and find additional space on a separate sheet, or if you have any space on this page, try part D as well. Okay, so part D, rotate it around x equals -1. Okay, so vertical axis of revolution. Obviously, it's off the shaded region. You know it's going to be washer method. And then we can reuse the equation that we built for part C. Right? The bounds and the equations are nicely set up for part C to part D. Yes, question.
There's one like that on the test. It's like do it but don't evaluate, but then you accidentally make myself.
No, but no, but definitely, you know, read the direction, especially on, I don't know about the AP exam. Hopefully they won't, but yeah, so just make sure you read the direction. Typically, if it's non-calculator portion of the AP exam, they typically just ask you to set it up and you won't accidentally work it up because you won't plug in the calculator. So that's usually not going to be an issue, but yeah, on this test, it's with a calculator, so I'll typically ask you to work it all the way through. Okay, go to page 2. Oh, sorry, page 10. Okay, again, work this through without a calculator, just so we can get that practice with that U substitution. And then parts B and C is just setup. Okay, area, top minus bottom. Top being the trig, and the bottom being the quadratic. So here's the setup. Make sure that you distribute the negative through the set of parentheses, otherwise it'll throw everything off. So yeah, when you never do top minus bottom or right minus left, watch out for the bottom, watch out for the left, especially if there's multiple terms. Got to make sure you have creating that set of parentheses is important, right? Otherwise it's going to be easy to be thrown off. Okay, most everything here is power rule, but there's a little bit of u substitution, right? You know cosine's integral is sine. 4 was going to tag along with it, but there's going to be something left over out of that pi over 4x. What's that going to be? I mean, we can go through u substitution, but what's the bit of a shortcut here? Get 4 over pi, right? So you find the derivative and then you just flip it, right? It's basically like chain rule for derivatives, but then you're just making that slight adjustment because you're going backwards. So if you look at this, you can understand this u substitution, but you can kind of speed your way through it, make it 4 sine a power 4x with a 4 over pi out in front. And then the rest is just, yeah, so the 4 stays, cosine becomes sine, the parentheses stays. You're just taking that parentheses, find the derivative and flipping it. So there's that 4 over pi in front. Rather than having to go through this whole u substitution for a relatively easy u value. Now, if it's anything more complicated, then I would go through a full u substitution step, but usually these are quick. Okay. Go ahead and start with the upper bound. Minus parentheses, lower bound. And sine of 0 is just going to be 0. So,
How do you identify which function on the graph is g of x and which one is f of x?
right, so we kind of just have to know a little bit about the graph. You look at this parabola, right? This parabola is 2x squared. That x squared is positive, so you know it's going to be a parabola that opens up. So because of that fact that it opens up, that kind of gives you an idea that it must be this bottom curve. All right, try part B if you're good with A. So part B, notice that your y equals 4 is skimming the surface of the shaded region. However, just because the dotted line is touching the graph doesn't mean that it's this method, right? It's got to be up against the flat surface of the shaded region in order for it to be at this method. So even though it's touching, there's still this gap, right? And we got to adjust for that gap, so we have to subtract that gap out. So this washer method for part D. Yeah.
Are the tests all just gonna be FRQ like this?
Yeah.
Yeah.
If you look at the morning review or test review worksheet 3, it's going to be structured like that. So expect it to kind of look like that. Page 11, 12, and 13. So. All right, no questions with B. All right, part C, cross section. So decide which direction your base is going to orient itself. Is it going to be vertical? Is it going to be horizontal? Build the base, build the area, and then build the volume. Try part C. Okay, so with the remaining time, I'd like for us to start a little bit on the morning review for tomorrow. Let's just try number 1. So number 1 is finding area, but I'd like for us to practice doing top minus bottom and right minus left, just kind of get that flexibility so that we know how to work top minus bottom and right minus left. But try top minus bottom first. Any questions with part C? Oh, it's just in the back of the packet.
Oh.
Sorry, yeah, so just page 11 in your packet. I'm going to use that as the morning review for tomorrow. So I know it didn't say area, but I meant for it to say find the area. So what's something that you notice if we want to do top minus bottom for number 1? Got to split it, right? We have there's that dividing line where the top function is all of a sudden going to change. So we also need to make sure that we can find our endpoints as well as our critical points so that we can set up our integrals separately, right? We need two separate integrals if we want to do top minus bottom. So try that. Let me know if you have any trouble finding intersections or boundary values for your integral.
Yeah, so if it doesn't get to where you want to go, you can just put it in the limit. So play with your x and x max and y minimum, obviously you want your x to just play with those four values always. Well, not, this is the natural log graph, right? It starts at 3. It's not anything less than 3. So for the x, just make sure you start at 1. Yeah, set natural log of x minus 3. Okay.
Guys, so a common question that I've seen is when you're graphing and something doesn't quite fit in the graph that you're looking at, you can always go to window. You can always play with these four numbers there: x min, x max, y min, and y max. You can kind of, that allows you to stretch your x and y values out to wherever you need it to go. Especially if you don't want to be playing around with zoom in and zoom out. Sometimes zoom in and zoom out, you don't really know exactly how it's zooming in and out. So just know that you can if you just play with these four numbers, you can always move it to wherever you want it to see it. Or if it doesn't, you can always do kind of trial and error until you get to something that you feel comfortable with. Right? So under window, those are the four values you can play with to help you move your graph to where you want it to go. Okay, so that's part A. We have to split into two separate integrals. If I want to do right minus left, what adjustment do we have to make? The equation has to be rewritten in a different form, right? So what's given to you is going to be great for top minus bottom, but it's not so great for right minus left. So we have to rewrite it solve for x. And then your bounds have to be changed as well, right? We want to adjust our bounds no longer from left to right in terms of x. Now you're going to be from bottom to top in terms of y. Okay, so tomorrow morning I'm gonna go over the rest of this worksheet. You're welcome to work through this on your own, just for that practice if you like. The key is on the website. I did this. I went through the same morning review last year, so I did record it. It's on the website as well. If you want to watch that recording, you can. But tomorrow morning, 7:15. Make sure you bring your calculator. Make sure you memorize your formulas. I'll send out a reminder this afternoon.
I got 39.0526. So I did 39.0523.
That's fine. Very good. Yeah. Thanks. Bye.